Good morning, everybody. It's such a pleasure to be here. Thank you to DDL for this invitation. It's great. I've not been here for I had an interruption of about 8 years, and to be back and have this opportunity to see old friends and to see new ones is terrific. And as I think, as we've said, this is a bit of an experiment for DDL. If you don't try things, if you've never made a mistake, you don't learn. And I think it's extremely important to sort of have that message in terms of where we are in terms of innovation. So I make no apology that this talk is intentionally, well, it has to be relatively superficial and nuanced because innovation is one of my passion projects and it could go on forever. But so it's missing nuance, but it's all about a start of a conversation and provoking that conversation. And you can't do that without saying a few things that perhaps are a little bit provocative, constructively provocative. So, and the talk is credit to a whole bunch of people, particularly the committee, who have engineered the topic and guided me, but I've also talked to literally tens of friends, contacts in designing this and got an enormous amount of feedback. So this talk is very much a team effort. But I think to make it interesting, especially at 9 o'clock in the morning on DDL day 2, it's an unusual talk for me because it's not technical. It's more about emotional intelligence. It's more about experiences, difficulties, successes, a few, failures, a lot. And issues. So forgive me because I'm not used to doing these sort of talks in that sense, but I think it's intended to get you talking and thinking. So this is really important. Okay, so important that the Economics Nobel Prize was given for understanding how innovation influences economics. Prosperity. And I have no expertise in economics, but I read through the media and I extracted a number of key points looking at what the Nobel Prize was awarded for. It's all about change. It's all about managing change, renewal. But it's recognizing that some people win, a lot of people lose. That applies to a lot of things, not just products, but a lot of things in the world that we live in. And one of the problems is when you do win, one of your incentives is to interrupt that process because you want to succeed and you want that to continue. So in doing such as a community, what the prize was awarded for is recognizing that it's important to try and find ways to manage that and governance. So it's really important to support new ways of thinking. It's what we're here for. Try to overcome that resistance. But I think perhaps a pervading message to really reflect on today is it involves all sorts of people. It's not just technical, it's not just commercial, it's a whole community involved. So, okay, so let's go back and tell you some stories. And I haven't done this before, so there's some really new stuff that I'm going to talk through. I was a lot younger in 2000. I just joined what was the precursor to Vectura, founded in 1999. There are certain things that you remember in life. And in an innovation journey, there are certain moments in your life that really stick. And the problem is that those sort of dominate over the sweat and toil of the whole journey. But this is the street outside Gill Jennings Avery Patent Office, and we just got together with Arrakis and started looking. And I was the young kid, I was the boy, and there were all these impressive corporates who I was intimidated by. And we sat down at the table, and they presented. They presented a 2-page provisional patent application, which basically said, let's come up with a 50-year-old molecule to create a once-a-day COPD antimuscarinic. And I was full of enthusiasm, as I still am. I was probably a little bit less, more naive then. So they turned around to me and said, David, can you formulate this? Oh, yes, okay. So I said yes. And I actually was reasonably confident at the time. So why was I confident? Well, and I was talking to John Pritchard about this yesterday. There's history. So 1990, I graduated and I started work at AEA Technology, or Atomic Energy Authority as it was. And we were really good at aerosol science. There was an amazing community of people. And we set up at Winfrith, the Skunk Works, I would call it now, an experimental team that was purely experiments, where we played with every conceivable energy, aerosol generating procedure that was occurring in Chernobyl, generating data to go into the models. And so we had to generate a lot of materials, and both top-down, bottom-up processing, condensation, mechanical attrition, a lot of knowledge gained, a lot of playing around, understanding bulk properties and so forth. And you know, we found porous particles, we found coated particles. So all of the stuff that then fed into the future was all pretty well known, but we had no real engagement with the pharmaceutical industry, as was then. I was actually invited, my first ever plenary talk, 1996 in Cardiff, for the Aerosol Society. And I was seen then as an expert in what's called aerosol synthesis, making stuff through aerosol processes and understanding. And so we'd made things like superconductors, really complex materials, gas sensor prototypes, television screen phosphors, fire suppressants, really interesting fire suppressants, very close analogy to DPI formulations, virtually identical architecture. So a lot of things, proposed medical aerosols, but nobody in the pharmaceutical industry knew what we were doing, a different silo. And 1997, I realized that was where the opportunities were. So I jumped into CDFS, CDD at Bath University. Amazing community. What struck me, I'd come from that community, and I thought, the first thing in life, why are PMDIs and DPIs so poor? Why are they so inefficient? And it was a sort of sense of naivety, because we could make really efficient aerosols. So why? And of course, you all know why. Because historically, it's about matching. It's about meeting regulation. But I sort of had this naive optimism that we could really do a lot better. So sort of at that Vectura, so in those early Vectura days, we were in other skunk works. We were playing around with ideas, loads of spray drying, really interesting. It was one of my passions. I mean, we built loads of spray dryers that were completely homemade because the current ones you could buy weren't actually doing what we wanted to, and a lot of mechanical processing. So both top-down and bottom-up engineering. And we had this sort of idea that, we could dial up a performance, but ultimately what we had to do was to meet the industry needs. So that was a hard learning, but it was great because lots of people getting together, we had lots of scientists, but lots of input from the companies that we were working for saying, no, you can't do that. You can't use a spray dryer because we haven't got one. It's not GMP. You've got to use a mill because we've got one. So that dictated what we did as a group. And so learn fast. And hence that was really what fed into that optimism that 10 years later. And then, we were optimistic for good reason, because here was a follow-up bit of IP, which showed, we could get significant dissolution change. And so, we felt really good about that. Was it an innovation? Well, let's see. Because at that point, we've been creative. We'd come up with something new. But we also then faced with another challenge. We were a relatively small company, growing. Kind of lesson that we're all facing. Shorter money, necessarily, or limited budget. We had to choose. We had a really fascinating inhaled spray-dried insulin program, which was working really well. Got great data. And then we had this 50-year-old boring small molecule that if you were a scientist, you thought, no. So we sat down in 2002. It was the beginning of I think it was spring. Again, I remember that moment. We sat around the table. And we had a really hard decision to make. Do we follow the sexy line, or do we go with the boring one? And, history tells us we went with the boring one. We went with glycopyrrolate. which I think if we were purely academic, we wouldn't have done that. So then, history tells the truth, what happened. Many of you are well aware. But it turned out glycopyrrolate didn't need a control release. Serendipity, so we had to, again, pivot again. Didn't need it. It stayed on the receptors. I'm not a pharmacologist, but it stayed on the receptors a long time. But it was the most beastly hygroscopic powder I've ever come across. You micronized it in the following hours, you found a pool. And so we had to find a different solution, which was effectively the same technology, which was protecting it with there we go. So new IP that we filed, and then so is that innovation? Well, we'll see, in my view. But 2005, yeah, that was then a remarkable situation for Vectura. It was licensed, Vectura and Arrakis licensed to Novartis. Fanfare, huge biotech deal, fantastic. 5 years. So the question is, what is innovation in the context of what that experience? And so many years of experience, I've reflected on this. A really good book by a British peer and journalist, Matt Ridley. If you want to sort of have a thought-provoking look at innovation, this book goes through what I believe some really key points. So first of all, innovation is hard work. It's not about ideas. It's not about creativity. It's not about inventions alone. It's all of those combined together with a lot of sweat and tears. That's the reality. So, the quote is 1% inspiration, 99% perspiration. So we remember those moments, but it's the sweat in between and the difficult times that really matter. And I think a correct definition, in my view, of innovation is one that actually captures an understanding that means that we as a community can really create an ecosystem that is innovation friendly. And I think at the moment we have every group, every community has its sort of own view of what innovation is. My sort of proposal to you is that it's more than a lot of the interpretations that are made by different groups. And the most important thing about innovation is you have innovation ultimately when you change people's lives in our sense. So I like this quote: the true measure of healthcare innovation isn't how many tools we can invent or improve. It's actually how many lives we can improve. And I learned that working with the likes of the colleagues in GSK and in Pfizer, many pharma companies. They really had that clarity of vision. So, yes, ultimately, what we were doing did lead to products, and you can just say quickly, flash through a bunch of them. There were the original glycopyrrolates, and then the use of magnesium stearate, which sort of proliferated and used, and its value was recognized widely. And on top of that, as a community, we were involved in other innovations, unrelated, but stimulated by the same community. So, and that's really exciting when you're involved in that, but it's hard work. So what do we learn? First of all, a group of people who are very different, diverse, is really key. You create an environment where innovation can occur because you can disagree with each other in a really constructive way. And you have the ability to make really difficult decisions. Sometimes these are really difficult decisions. And I was talking to Chris at breakfast, and he pointed all sorts of things out about the difficulty sometimes of making the right decisions which have a market-driven approach. And you only learn these things by listening to people and their wisdom. And then this point about what stimulates innovation in terms of policy and understanding innovation. So again, doing my research, culturally, a lot of innovation is now seen to be following either a linear or non-linear model. If you read the the published research on it. And I'm very convinced from that, my own experience, that research follows what we call a non-linear model. In other words, it's not driven by research. Research is a critical part of it, but innovation actually starts with problem solving, with a community that has something that really needs addressing, often experimental in our sense. And what Ridley says is science is not the mother of invention, rather innovation is more the mother of science. And his big quote is that the steam engine came before the science of thermodynamics. It was that built the science of thermodynamics, not the other way around. And it's a really good insight. The other thing, and this is perhaps more controversial, but I talked about the fact that we could easily have been seduced by the sexy side of the research that we were doing. I was I was motivated by my spray drying research. It's the most exciting area, but I kind of was pushed off it. And if you look now at where we are, if you look at, you look at a lot of technical reviews of innovation technology, you'll probably have about 3 lines on co-milling and dry processing and coating and using magnesium stearate, and about 3 pages on spray drying. But if you look at the products out there, it's the reverse. There are so many more products out there that use particle engineered, dry coated, the practical, let's say, slightly less exciting, but actually technically really hard to do. And that's what it took us 10 years to get there, to get that right. And so, there is this balance of what is absolutely innovative and creative versus what the market needs, what the market tolerates. So again, these are things that are hopefully are a little bit provocative. Very quickly, I'm just going to give you a bit of context to what we're talking about. So Mark, I was talking to yesterday. Mark is the father figure of the history of innovation, and his article on the history up to going back and showing that humanity knows inhalation's a good thing. It works. But it was really the 20th century where it took off. And you can see the list of what probably are the main events over the last 100 years. I think perhaps the most important, the most significant to us was the PMDI. It just changed everything. You have a functional, portable, personal inhaler. Changed everything. But then, we saw a real expansion. Everybody started developing dry powder inhalers. And then we saw the CFC-HFA transition, which is now history repeating itself on us, driving innovation. It drove innovation, not just the transition, but everything else sort of seemed to happen. So smart mists, nebulizer technology, all of these things, formulation technology, all really pivoted. And then there's a great paper by Omar and Francesca that basically sort of says, well, what happened then? And so we came to a point, did we run out of innovations? And Geraldine Ventoy, I'm not sure if she's here, but I saw her report of the RDD, and she sort of said that since about that period, innovation progress was glacial in progress. Now, a bit controversial, but I think, it's a really interesting point. Have we slowed down in that process? So, I just wanted to have a look at that. So, developing inhaled products is hard. It's a really complex process. You've got to get these 3, aerosolization, transport, deposition, you've got to get these right. And there was a DDL paper in 2008, which sort of really reflected this really well. So, again, this is nothing new. And, this great paper by Dolby and Suman, which I'm always quoting, it also involves a lot of people. It's not just a DPI or a device. It's not just a formulation. It's a patient. It's really involves a lot of people. So innovation has to be a team sport. It involves a lot of people, and they've all got to get on. They've got to work together, and they've got to have a really effective long-term relationships. And perhaps the most interesting thing, so those engineers amongst you will recognize the double diamond design approach, which is sort of standard in engineering design, but it really applies quite nicely here. So you have this divergent creative moment, but then you've all got to get together and have a convergent, disciplined. You've got to make decisions. You've got to cut down to something. And then you've got to open up again. And the DPI, the PMDI, the inhaler development process actually is a whole string of these diamonds, a whole series of divergent, convergent processes. And that's why it involves a lot of people, a lot of time. And that leads to, so the second, just brief story. Last time I was talking here, 2012, invited to talk about the program we had with GSK in Australia. And a year after that, we were awarded the National Award in Australia for the best collaborative research program. Amazing. It was a real, but I have to say, personally, I found it really, really exciting, but I also didn't really quite understand what we'd done to deserve it, because we just did the sensible things really well. But it did cause a bit of an issue, and it was a real learning process to me. So, we had a lot of projects that were involved in real products, over 20, looking at manufacturing processes, and we've got students involved, immersion into understanding what the problems were and then working on them. Great impact, great innovation, because this affected real processes that went into real products. And a bit of a joke, it was called the Center of Innovation and Industrialization. And I had this hallelujah moment, and I said, actually, it's the Center of Innovation. So industrialization and innovation, swap them over. Because innovation comes from the industrialization, not the other way around, which goes back to my non-linear point. It's a bit of a joke, but it's so true. It was a lesson to learn. And then sort of things weren't quite so happy. So there was a publication in the national press which celebrated a major impact from one of the projects we had, which was putting vaccines into blow-fill-seal. The problem was here that there were a number of things. This work was done by an undergraduate, which the industry and the government really loved, but within the academic view, that's not a great advert. Research is done by postgraduates and professors. So it got a little bit of sort of stick for this. And then I said some things I shouldn't have done, which was really naive of me in the sense of understanding innovation, because innovation came from the relationship. And so, and here's an example I saw in October this year from Nature, which actually talks about the fact that really good innovative research tends to be dominated by naive scientists. And again, you can understand why this is not a particularly comfortable view with an established academic. Again, this is provocative, but this is something that I found, and it's a cultural barrier that you often find. So there were interesting things. Ultimately, it meant that I ended up by leaving Monash. It was sort of quite a pivotal moment for me. I was stupid, but sometimes you make these mistakes. So that's the end of my sort of main theme. I got this fortune cookie about 10 years ago, and it said the conclusion is the place you stop thinking. So I put it up to say, this is the place we start thinking, right? Okay, I've given you a couple of stories and my own personal perspectives, but what matters now is what you think. It's not what I think. I can tell you what I think, but it's what you think and what you believe and what you want to do. So in summary, there are real issues with understanding what and measuring what innovation is. It's a huge issue. It's much bigger, I think, than most people realize, and it causes a lot of conflict. So these sort of points summarize really what I've just said. Number of key things to think about in terms of innovation. What I haven't had a chance to really dig into, but these are big issues that I just want to put up for you to think about. So we have changed, the industry has changed in that period since 2010. A lot of big pharma changed their strategy in terms of R&D. A lot of you here will have witnessed that. Similarly, and I could spend all day talking about this, there are cultural issues, now well reported, but are not necessarily comfortable in academia, which do inhibit the ability to have the freedom to try really new things. And fundamental research is so important, but we seem to have a system which tends to fund applied research under the guise of fundamental research, so you kind of get halfway, and we don't have the freedom to really play in many academic projects. They have to be justified, and I don't think that's necessarily a good thing. And then, who trains the next future of you, of us? And I think that was why at Deakin, I specialized in professional education, because I saw it as an enormous gap. And something that this is a personal bugbear. I think one of the biggest issues in research which inhibits what we do is the heroic inventor. And Wrigley talks about this. There's no one person is responsible for innovation. It's a whole team, equally valid. And I think if we persist with overplaying the heroism, the individual success in an innovation, in research, yeah, but in innovation, no. So I think we have a problem there. I won't say the details, but an academic when I first started said to me, "David, you will never be a successful academic because you make other people look good." And I thought, I didn't understand what he was saying. So they were saying, but actually, I think it plays into this, and it's not the individual's fault; it's the system. So, it's part of my. Many of you will be aware of the issues with IP, both on the industrial and on the academic side. I have seen all sorts of issues compounded, particularly in academia, through the transition to a sort of much more commercial mindset, which arguably is driven by the Bayh-Dole Act in the US about ownership of IP. Again, it's a whole day to talk about that one. And then finally, in the last couple of slides, why are we optimistic? Well, just look at you. Look around. We have a community here that has so much potential. I think what I perceive to be the case is that new generation often are the CDMOs and the smaller SMEs that are as Vectura did, carrying the can, but it's hard. It's really hard. I think we're seeing a changing of the guard. It's really interesting to learn that regionally, innovation is occurring in other parts of the world, particularly in China, who have a much longer view of innovation and investment. So, look at deals recently. So many are coming from that part of the world. Okay, so we could, I won't spend very long on here, but you can read them. There are various areas where I think we will hear today, we will hear over this community where innovation is occurring. Perhaps the one that I like the most, and people have heard me talk and rant, cost of goods is something that we perhaps don't look at enough. Affordability, and the World Asthma Day this year was make all treatments accessible to all. So what is it? 90% of Americans can't afford basic inhalers, or something that I think Vicky relayed 10 years ago when I asked this question. Still, it's a really important question. Affordability is something that perhaps we as scientists don't spend enough time on. And of course, who funds it? And then hopefully we'll come back to this in this discussion. So that's my last slide is really just to challenge to us as a community that we have the potential. I think we can't do it individually. We have to do it. We have to have that shared knowledge and insight to make it work. And Russell helped me with this word, so thank you, Russell. But I think it's a very important message that we have this potential to be brave. Gerhard was talking about this yesterday, a superb talk about what we need to do. Finally, I love Bill and Ted because they perhaps exemplify everything, the wonderful naivety, optimism, but also the ability to cajole a group. Anyway, people who've seen Bill and Ted's Excellent Adventure will know that it is underneath the sort of message is something of actually really important to innovation. We've got to be really humble about who we are. We're not the most important people in the room. We've got to work together, and we have got to be excellent to each other, and so forth. So anyway, I will leave it at that, but thank you very much. This is a great opportunity, and it's all about you now.